everyone. So in the computer networks lecture series, the topic that we are going to discuss is on congestion control. So this is from unit 4. So I'll introduce myself. I'm Logesswari. I'm from CSE department, working as an assistant professor in RMD Engineering College. Let's move on to the session. So before that, I want to know what is mean by congestion. So actually it is one of the basic responsibilities of TCP. That's why we are combining both IP and the TCP while we are transferring the data packets. So what is meant by the congestion? Congestion is defined as the heavy traffic in the network so that it will lead to the data loss. So that is the main concept of the congestion. So we have to control the congestion. We can't able to avoid the congestion. Instead of that, we can able to control the congestion in the sense once it has been happened, we can able to control the data rate. So that is the concept of the congestion. Okay. So the idea of TC congestion control is for each source to determine how much capacity is available in the network so that it knows how many data packets can be safely it can able to transmit. Okay. So the first method that what we are using. Okay. So the first method that what we are using in congestion control is called as the additive increase and multiplicative decrease. So before that we'll use some term called as congestion window. So congestion window is that it is an acceptable window size that will be used by the sender and the receiver. That is a common window size. So that if I use this particular window size, it will avoid the congestion or control the congestion. That's why we are using the common congestion window size. Say for example, if I have a 7 data to transmit means I won't use the 7 data. Instead of that, I will use minimal of that 7 data like 5 or 4, so that it will, if there is any congestion, it will avoid the data loss. That's why I am choosing that as my window size. So that is said to be the window congestion window, which is used by the source to limit how much data is allowed to be transmitted in a given time. So that is also called as the advertised window. So here in additive increase and multiplicative decrease, additive increase means one by one I will increase my data packets. Say for example, initially my window size will be get increased. Like initially I will be sending one data packet. Once I got the acknowledgement, I will be increasing. Okay, like step by step, linearly I am going to increase it. So if there is a congestion, I will reduce my window size. Okay, how it could be determined means once it reaches the threshold value means automatically it will reduce the congestion window size by 2. That's why it is called as the multiplicative decrease. So once the router finds that there is a congestion is about to happen means automatically it will give information to that sender. It will cut down the data rate. That means it will cut down the window size. That's why it is called as the multiplicative decrease. Okay, so here we are finding out, in this way we are finding out maximum window and the effective window based upon the formulas. Maximum window size is the minimum of congestion window and the advertised window. Effective window size is the maximum window size minus last byte sent minus last byte acknowledgement. In the sense how many bytes has been sent and how many bytes has been acknowledged. So that's why it is given here. So this is the main thing. And then so this is the additive increase and multiplicative decrease. So here you can see at the like at the fourth point. For example, suppose the congestion window is currently set to the 16 data packets. If the loss is detected, the congestion window is set to 8. Why? I will divide by 2. 16 divided by 2 is 18. So automatically it will reduced. Okay. So if more number of losses are been happen means automatically it will be decreased by 2. So that's why it is called as the additive increase and multiplicative decrease. So you can see the diagram. So you can see this diagram. So in this diagram, initially I have sent only one data packet. Once I got the acknowledgement, I will be increasing the value to be 2. And then once I got acknowledgement for the 2 data packets, I will be increasing to 3. Likewise, I will be increasing linearly. Okay. So this is the main concept behind the additive increase and multiplicative decrease. And then next one is the slow start. Okay, so next one is also called as slow start. In slow start increases a congestion window exponentially rather than linearly. So why we called as, what is will be exponentially 2 to the power, okay, in terms of 2 to the power. So once there is a congestion has been happened, on the time multiplicative degrees will plays a key role here. So it will, once initially I will starts with 2 power 0 and 2 power 1, 2 power 2, 2 power 3, 2 power 4. Likewise, I will be increasing more number of data packets. When the source starts out sending the congestion window to one packet, when the acknowledgement for this packet arrives, TCP adds 1 to the congestion window and sends 2 packets. Upon receiving a corresponding 2 acknowledgements, TCP increments. So congestion window by 2. So likewise it will be increasing each and every time, doubles the number of packets it transmits every RTT. So two situations in this slow start runs. The first is that very beginning of the congestion, it doesn't know how much idea about how much data packets is to be sent. It will send on the time it will be sent. So when there is congestion has been occurred, that means if there is any loss has been happened, automatically it will gives us the multiplicative degrees to divide the window size by 2. So or else if it reaches a threshold also, on the time also it will divide the window size by 2. So you can see that. So as a timeout in the slow start is used, rapidly increases the sending rate of the value and additive increase is used. So here as a timeout happens, causing the window divided by 2 and dropping the congestion window divided by 2 here. So at the same point is going to be repeated here also. So as I said earlier, if there is no problem at all, it will be reached, it sends a data packets exponentially. If there is any loss or if it reaches a threshold, means automatically it will decrease the window size by 2. And then finally we have another concept called as the fast retransmit and fast recovery. So in this fast retransmit and fast recovery, here the receiver is going to play a key role. So generally what will happen, if I am sending the data packet if I didn't receive the acknowledgement within the time period, what will happen? If I didn't reach the acknowledgement within the time period, what will happen? It will assumes that the data has been lost or the frame has been lost, and then it will do the retransmission, right? But it has to wait now. So here that sender is the receiver is going to give the information to the sender before the timeout, so that it will reduce the time. Okay, so it will send the duplicate acknowledgements. It will send 3 duplicate acknowledgements. Okay, it will send 3 duplicate acknowledgements to the sender, so that sender comes to know that so there is an congestion is going to be happen. So we have to reduce the data rate. So in this way, fast retransmit and fast recovery will work. Okay, thank you students.